Have you ever wondered what is dynamic programming? Ever faced challenges in optimizing a brute force solution? Ever received a TLE in a programming competition? If yes, you've come to the right place. Welcome to Developedia, where I teach you complex programming concepts with ease. My name is Amartya, and in this video let's talk about Introduction to Dynamic Programming. Let's begin with dynamic programming, or DP in short. Following is a screenshot from Wikipedia where it says that solving a problem by recursively dividing it into smaller subproblems and then reusing the pre-calculated result is in fact dynamic programming. Now, how do we do this dynamic programming? And please don't freak out because I'm not going to make it too complicated. I have divided the process into few sub-processes, and if you follow, it's going to make your life easier. So here we go. First, try to identify the problem and the subproblem. Write a recursion relating to the problem and the subproblem. FYI, this is the most important step in dynamic programming. Memorize your solution and make your solution bottom up. By the way, this step is optional. I personally prefer the top-down approach. Now let's understand this concept with the help of an example. Fibonacci sequence is a sequence where each number is the sum of previous two numbers, starting with 1 and 1. As you can see here, Fibonacci of 5 is 8, which is a sum of Fibonacci of 3, which is 3, and Fibonacci of 4, which is 5. So 3 plus 5 is 8. So Fibonacci of 5 is the sum of Fibonacci of 3 and Fibonacci of 4. And the problem is to find the nth Fibonacci number for any given n. Now let's try to come up with the solution with the steps I had mentioned before. The problem is clearly to find Fibonacci of n. The subproblem is to find the same for n minus 1 and n minus 2. Now how do we choose the subproblem? We should choose something that can participate in a recursive relation to form the original problem. In this case, if you add Fibonacci of n minus 1 and Fibonacci of n minus 2, you get Fibonacci of n. So this looks like a good recursion. Alright, let's code the solution up. I've written a code in C++ as well as in Python so that you can follow whichever you're more comfortable in. This Fibonacci method is just a representation of simple recursion where you have the base case for n is equal to 0 or n is equal to 1, otherwise you recurse. Pretty straightforward. Now let's execute this. Alright, Fibonacci of 6 is 13 indeed. It works. Now let's try running the Python code. Alright, this runs as well. Now let's talk about the recursion tree and time complexity. As you can see from the screen, the recursion stack in each branch goes as deep as long as it doesn't encounter the base case. But the problem of this approach is that a lot of recalculation is made in the course of the execution. For example, the Fibonacci value of 3 is calculated here and it's again recalculated in here. The same goes up for Fibonacci of 2. Therefore, the tree goes deep and keeps bifurcating on and on until it gets a 0 or a 1, and thereby gives a time complexity of 2 raised to the power n, which is exponential. Now this exponential time complexity is definitely not a good complexity. The program executes terribly slow for larger values of n. Now to improve the complexity, we use a concept known as memoization. and this step is what turns a brute force solution into a DP solution. The idea of memoization is to store the already calculated results in the subproblems in a memo table and thereby avoid recomputation. In this case, we store the Fibonacci values of the problems we see. It serves our purpose. Alright, let's memoize the solution. We are creating a memo as a map or a dictionary in case of Python, and we are storing the values, the Fibonacci values of n that we have already computed, and instead of recalculating it once again in here, we first check if it is present in the memo. If it is present, we just return the value directly from memo, and thereby we avoid the recomputation. Otherwise, we calculate it and store it in memo for future uses, and then we return. Now let's try to execute it. Yippee! Fibonacci of 6 is 13. Yeah. Now let's try the Python one. Yeah, 13 indeed. Cool. Now let's take a look at the recursion tree for the solution. You can see that each node is computed exactly once. So as 5 is expanded only once, 4 and 3. 4 is expanded only once, 3 and 2, and 2 is expanded only once, 1 and 0. So the complexity is linear, O of n. Alright. Now the last step is an optional step. It is making the top-down solution a bottom-up one. Well, let's take a look at the steps as well. Now this step includes basically, so first we create an array of dimension according to our use case, and we fill in the base cases. We iterate over the array until you get the result that you need, and then you return the result. It will be more clearer with the code. Let's take a look at this. So what we do in here is that we create a result of n plus 1 according to a Fibonacci use case, which requires finding the Fibonacci of n. So we create an array of size n minus 1 so that we have values from ranging 0 through n. Now we fill the base cases with 0 and 1. Then what we do is that we just iterate from 2 till n, because n is the result that we want. And we do that by doing this. Result of I is equal to result of I minus 1 plus result of I minus 2. And once we have the value of Fibonacci of n, we just return. That's it. Alright, pretty cool. Alright, this one works as well. And with that, we come to the end of this tutorial. GitHub link to the codes is provided in the description. Please like and share this video if you enjoyed it. Catch you guys in the next one.